Howdy, this is the chapter 14, video 4. We're going to finish this. We've got about, if you go through Dr. Conklin's slides, about 20 slides to go through. Again, listen to what I'm saying and emphasize what I'm emphasizing. In other words, when I tell you this is important, it's important. So now we're going to talk about patch management. And patch management, it's a disciplined approach to the acquisition, testing, and implementation of operating systems and application patches. It requires a fair amount of resource to implement properly. So think about it. First of all, you need a good inventory of the software used in your environment, including all operating systems and applications, which again can be complicated if you have various, Linux, Windows, Mac applications, as well as different applications such as database, customer interface software, specific scientific applications, whatever the gamut. So first of all, you need to have a good up-to-date inventory. And then you have to set up a process to monitor the updates for those software packages. Many vendors provide the ability to update their products automatically, or they will automatically check for updates and inform the user when updates are available. So keeping track of patch availability is merely the first step in many environments. Patches must be analyzed and tested. Does a patch apply to software you have running? Does a patch address a vulnerability or critical issue that must be addressed immediately? What is the impact of applying that patch or group of patches? Will it break something else if you apply that patch? This is extremely important in an integrated, complicated enterprise environment. Excuse me. So to address these issues, what are we going to do? Well, it's recommended that you use development or test platforms where you can carefully analyze and test patches before placing them in the production environment. So while patches are generally considered good, they're not always exhaustively tested, and of course it's tough to test interoperability with other software systems. Some have been known to break other products or functions within the product being patched, and some have introduced new vulnerabilities while attempting to address an existing vulnerability. So the extent of analysis and testing varies widely from enterprise to enterprise or organization to organization, and testing and analysis will always vary depending on the application of the operating system and the extent of the patch. So first of all, you need to have an inventory. Second of all, you need to test your patches, analyze and test them, and then once that's done, you need to determine when to apply the patch. As many patches require restart of applications or services or an even reboot of the entire systems, most operational environments will apply to patches only at specific times. So they want to reduce downtime and possible impact and to ensure administrators are available if something goes wrong. Many organizations will also have a rollback plan that allow them to recover systems back to a known good configuration, i.e. your baseline, prior to the patch, in case the patch has unexpected or undesirable effects. Some organizations require extensive coordination and approval of patches prior to implementation, and some institutions will lock out dates where no patching or systems changes can be made to ensure that business operations are not disrupted. For instance, you don't want an e-commerce site trying to do major patches during Thanksgiving and Christmas holidays, because they want to ensure that the site is always available to their holiday customers, where, of course, that's the most profitable time of the year. So patch management has a lot of issues and a lot of process built into it that you need to know. So again, you have a process. Know your inventory, test and analyze, implement, how you're going to implement, how you're going to schedule, and with any environment, especially the larger ones, it can be a challenge to track the update status of every desktop and server in the organization. I think I showed you something earlier about the 5 NIST aspects of cybersecurity. If I did not, it's identify, protect, detect, respond, and recover. It used to be 4. But in this days of dynamic networks, it is amazing that we will have networks in place, systems in place, and yet we do not know what computers, hardware devices, everything is attached to that network. So they came up with the step of identify and know. And I know it's one of these things that I tell you now, and you won't believe this is true until you get out in the real world and realize that a lot of times environments, because they are so dynamic with people adding and taking away software and machines, that there's not a good inventory. And worse than that, for every asset on that inventory, and by asset I mean computer, router, switch, what have you, you should know the configuration. On the computers, you should know what software is running. For every software, you need to know the configuration, the like. It's a challenging problem. So it's a challenge to track that update status when you consider every desktop and server in the organization. And so documenting and maintaining patch status it's a challenge. And that's usually why companies will go with commercial patch management systems. This requires a disciplined approach. It requires trainings, policies, and procedures. Even the largest environments can be managed. And many times, as I said, they use a product that automates many of those mundane and manpower-intensive tasks. So if you're looking for a patch management product, it should provide, first, the ability to inventory applications and operating systems in use. Second, notification of patches that apply to your network, apply to your environment. 3, periodic or continual scanning of systems to validate patch status and identify missing patches. 4, the ability to select which patches to apply and to which systems to apply them. Did I say 5? The next one's going to be the ability to push patches to systems on an in-demand or scheduled basis, the ability to report patch success or failure, and the ability to report patch status on any or all systems in the environment. I have just spent almost 6 minutes on the first slide. Why? Because I consider patch management important. Let's look at host software baselining. Sometimes called the default or the gold or the standard configuration, a software baseline contains all the approved software that should appear on a desktop or server within the organization. While software baselines can differ slightly due to disparate needs within groups of users, the more standard a software baseline becomes, the easier it will be for administrators to secure, patch, and maintain systems within the organization. So what do you need to know about this? In an enterprise, you have difficulty with people sometimes trying to install or perhaps being successful in installing their own software on their company computers. Bad idea, all right? So you need a software baseline of all software that should appear on a desktop or server, and you should have something that comes in and audits that. So something that comes in and can do an inventory and analysis and say, wait a minute, you have software that you have loaded here or you have downloaded from the internet or something that is not allowed. So a vulnerability scanner is a program, and it's going to probe, it's going to look for weaknesses, misconfiguration, old versions of software, and we've talked about these before. At the network, it's going to probe host for issues across network connections. At the host level, the computer level, it's going to run a specific host and look for vulnerabilities, and the application vulnerability scanner is going to look for vulnerabilities within that software application. Another group policy is an infrastructure, according to Microsoft, used to deliver and apply one or more desired configurations. You can read the definition. Group policies are not just defined by Microsoft. Group policies mean just that. You're going to have a targeted set of users and computers that comprise a group, and you're going to manage to the groups, not to the individuals. So that way you can write group policy responsible for specific policy settings on those computers. So again, with group policy and a globally unique identifier on the operating system, we have many useful options. We talk about network location awareness, so systems are now aware of the networks they're connected to, the ability to process what specific packet level that you're going and what operating system version, compatibility with VPNs, power management, device access blocking, location-based printing, whatever. I don't consider the specifics to Microsoft that important. I do consider that you understand how group policies are formulated. Group policies in general mean you target a certain set of users group of users, whatever. There's some commonality in the organization. And so when you update settings on that group of users or systems, not on an individual user or system basis. Then you have things called security templates, and they're a collection of security settings that are applied to any system. So again, defaulting to Windows operating systems, you have account policies, event log settings, file permissions, registry permissions, restricted groups, etc. Basically, again, it's a collection of security settings that can be applied to the system, and there's hundreds of settings. So you basically have a template, and typically you have you have set defaults that then you can go in and modify and fine-tune the template to create the system that you need for your environment, more or less secure. And here's just an example of that. So here is something I consider important that I am surprised that Dr. Conklin does not give more credence to, given his area of expertise in this. But we're going to talk a little bit about alternative environments. And these are not traditional computer systems or common IT environment. I've talked about these before. OT, operational technology environments, are not IT environments. OT environments, two words to think of, highly automated. They are not rare. They are alternative environments, and in fact, I believe they may outnumber IT environments now with the Internet of Things. There's millions of these systems. They're composed of hundreds of millions of devices. They're all across society. But because we don't interact with them directly, we tend not to think about them. So we tend not to think about the industrial control system that provides water, that provides wastewater, that your power works when you turn the light on, that your air conditioning works, any of this critical infrastructure. So SCADA systems, industrial control systems, OT systems have their own set of critical functions tied to that system, and they have their own set of cybersecurity issues. And what is important to know is you do not protect, defend, respond or recover to an OT incident as you would an IT system incident. For instance, worst case, my IT system gets attacked. I don't know anything else to do. I shut it off. My customers are upset. My e-commerce site doesn't work. You can't access money out of your bank account, whatever. In an OT system, perhaps the worst action you can take is to shut it off, because it actually may put that system in a state that will pose a risk to the health, safety, and well-being of people, such as a nuclear power plant. You don't just shut it off, okay? So I'm going to go through these quickly. He talks about alternative on the mobile devices. If you're interested in that, great. They all come with their own problem. I don't consider this that important to this level of class. I do consider what I talked about, the ICS and SCADA systems, to be so. Mainframe computers. I'm old enough to know that I started my career on mainframe computers. People think they've disappeared. They have not. Our government runs largely on 40 or 50-year-old systems, God forbid, running things that like Social Security and other stuff are big systems. They're still very much alive. They're high-performance machines, large quantities of memory, computing power, storage. They run old, I shouldn't say old, but they ran for decades on high-volume transaction systems. So a lot of them are still used as legacy systems, but they're still there. You're all too young to remember when everyone was concerned about Y2K and having something blow up. And one of the things that happened is they found all this legacy COBOL code, and they couldn't find COBOL programmers because a lot of your transactions built in the 60s and 70s and the like were built on COBOL in the mainframes. Surprisingly, these still exist. We have become acclimated to having our laptop and our smartphone, and we forget about that there are still large mainframe systems that will continue to operate. Game consoles, not really that much of a gamer, but these are a big risk. You need to remember that the first Sony breach on the PlayStation was from a game consoles. So, that operating system was designed for a specific purpose, and the updates are provided by the console manufacturer. It's a closed environment, but it's still a reasonable risk of associated with the security systems when they are connected to something like the internet for things like, payment processing. This is going to be a big one. In-vehicle computing systems, autonomous vehicles. We don't know where this is going. We have some level of in-vehicle computing systems with embedded systems on my engine functions, environmental controls, dashboard displays. My SUV beeps if I get out of the lane. My SUV beeps if I'm backing up and it detects something. It's all great to have. What this is going to lead to then is, as we go and this technology progresses, more vehicle-to-vehicle communication, vehicle-to-roadway communication, more automation. So your security risks are going to increase and become obviously a pressing issue. So many of the alternative environments are different, and he calls them static systems, which is fine. I'll defer to that. But everything assisted in securing the network connections between these systems are different. The network segmentation, the security layers, the wrappers, the firewalls, what you can do, when you can do it. So you need a wide range of security techniques employed. However, you also have to realize that in a lot of the highly automated systems, the industrial control systems, you cannot use your typical prevention and detection systems because of the essential timing in the automation. In other words, if you try to use virus detectors, intrusion detection systems, something like this, many times it creates too much overhead. The timing has to be synchronized, one reason. So there's a wide range of security techniques in these, and they may or may not differ from alternative systems, and they may differ a little bit or a lot. Just be aware you can't use the same. So one of the challenges of this is the devices themselves may not have typical security controls such as access controls or encryption, including by default. I was at a conference at Purdue last year, 2017, for their annual information symposium, and one of the speakers made the comment that with the pervasiveness of the IoT devices and the fact that most of them have default passwords that never get reset, his comment was, we have weaponized the common citizenry. Okay, in other words, we've put guns and machetes and powerful tools, weapons in the hands of people who didn't even know that there was a password on their refrigerator or something. So again, the network segmentation, all of this is going to be very different and challenging in these environments. We go back to security layers. We go back to one of the first principles, defense in depth, layered security. Each needs to achieve some part of the security solution that leads to more robustness. You just have to remember that in the alternative environment, not everything will work as it does in our traditional IT environment. This is droning on about this, the policies of firewalls, sometimes a requirement to do manual updates. We want to control redundancy and diversity. These are all good techniques. But we're going to end this chapter. We've talked about a lot. So you need to go through this chapter and you need to listen to what I emphasized about hardening operating systems and network operating systems, implementing host level security, hardening applications, establishing group policies. And you need to pay special attention, if not to the mechanisms to secure alternative environments, but a recognition of the problems. This ends chapter 14. Thank you for sticking with me.